Mr. Lesham is here, and this is our last lesson on functions. Okay, advanced graph interpretation. We're still working with graphs of different functions, and we still interpret it. But the question you're going to come across today are higher order skills. I would say, I don't know if you know, there's level 1, 2, 3, and 4. So we're looking at level 3 and maybe even level 4s, okay? Difficult ones, okay? So we've got a linear graph, we'll call it f of x, okay? In this case, you're told it's 2x minus 7, okay? I just want to make sure I got, yeah. And then we've got a g of x, a parabola, quadratic equation, x squared minus 6, x minus 7. I'm not going to look for the intercept or anything like that. What I'm told is, if this is point A and this is point B, the points where they are equal, okay? There is a certain point, a line, PQ. That line is perpendicular to the x-axis, and I can move it. It can be there, it can be there, it can be there. I can put it anywhere I want between A and B. In maths, we call it like this. The x of p, the x here, we'll call this xp. The x coordinate is between the x coordinate in A or the x coordinate in B. What we're looking for is, what's the maximum length of this line? Can you see that if I draw this line here, this line is shorter than that, right?
Yeah.
If I move a little bit, it gets bigger, 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 bigger. Okay? And if I move past this point, it's going to start getting smaller. So I'm looking for the maximum it can take. Okay? Now, how do I not do it? How do I not do it? I do not just take my ruler and try and find, oh, this is, I can move it a little bit to here, use the ruler. No, that's not how we do it. Okay? We have to use some proper maths. Okay? So, to get the answer, let me first of all ask you, how do I find the distance between those two? Doesn't matter the maximum, but just the distance between two graphs. That we did last time. Yes? No, we're not making them equal. What is the difference? Find the y value. Find the y value of the red graph. Find the y value of the blue graph, and take the difference. Okay? Now, obviously, we won't get a number because we don't know what the x is, but the first step is to actually write down what is it equal. So we're going to write down, I'll write it here, PQ is equal. Which one is above? So which one should we put on top? F of x. So I'm going to write this bit first, okay? It's going to be f of x minus g of x. Okay, that's really, you're not getting any marks here, but just to explain what we're doing. Now let's write it properly. What should I instead of f of x? 2x minus 7. Okay. What about g of x? X squared minus 6x minus 7. As it stands, I've got a mistake. A fatal mistake here. Brackets, well done, Joey. Okay? We must write down the brackets. If we don't write the brackets, then we're going to get some science problems.
Isn't 2x minus 7 in brackets?
You don't have to put that in brackets because it's not gonna affect anything. Okay, I'll pause for questions. Okay, so now I have this expression for PQ. Let's write it a bit nicer. So I'm gonna have, well, maybe I'll write it down here one more time. 2x minus 7. Because we were good and we put the brackets, then it's going to be minus x squared plus 6x plus 7. You see why the brackets are really important. Otherwise, you'll get the wrong signs here. Tricky, it's very naughty, okay? Now I'm going to rewrite it nicely. Start with a quadratic term because we are civilized people. Why we want a quadratic term first? Minus x squared.
Plus 8x.
Well done. Okay, you've done it for me. Plus 8x.
0.
Done. Okay. Let me just see that we got it right. We got it right. Okay. Now that is the length between the two graphs for a given x. If I say, okay, x equal 2, I can put it here. And minus 2 squared plus 8 times 2, I'll get that answer. If x I decide is to be x equal 1, I'll put 1 here and I'll get an answer what's the distance. How would I find the maximum? I'm looking for the maximum length. I want to just see what you guys are going to have to say for that. So I've got a fantastic answer. Well done, Jojo. Again, well done. Okay. Currently I've got the function of the length of PQ. PQ depends on x. If I put x equals 0, I'll actually get 0, which makes sense. Cool. Here's PQ is 0. If I put x equal half, I don't know, I'll get an answer which is a bit bigger. 1.5, I'll get maybe bigger. Maybe it's too small. I don't know. Okay? So one option, one way to go is to just put different x's. X, and make the x start from 0, go 0.1, 0.2, and see until it goes up, and then suddenly goes down.
Yeah.
But a more clever way is to realize, hang on, I remember in the beginning of the year, it's quite amazing that you remember that, Jojo, that in the beginning of the year we said, if I want to find a min maximum problem, I got to complete the square. This is a quadratic equation, so all I got to do is complete the square. And the completing the square will tell us what is the maximum that PQ can be. So the first step is to realize when I complete the square, I want this to be just x squared. I don't want it to be minus. I don't want it to be 2x squared. Okay, I'm reminding you now. Okay, so we want to get rid of this minus. We do that by just putting a minus there, and then rewriting it in the bracket. So now I'm going to have x squared, and what will I have here? Minus 8x, right? So if you multiply it again, minus x squared minus time minus 8x will be plus 8. Okay? We alright with that?
Yes, sir.
Okay. Now, what you shouldn't do, and I know some of you want to do, is you want to take x out, isn't it?
Yes, sir.
That's how we solve, but that's not the right thing. That's not, we're not trying to solve it, okay? Because the thing is not equal to 0, okay? If you had, let's say, minus x squared plus 8x equals 0, yes, then what you should do is take an x out. You're going to have x minus 8 equal to 0, meaning x equal 0 or x equal 8. That's incidentally these two answers. This is where, okay, these are the roots of this equation. But that's not what we're interested in. What we want is to find where it's the maximum. So what we're going to do is complete the square. So we still have that minus now. Now I'm just going to remind you, you probably forgot. But what we're going to do is we're going to do x minus something squared. What should be that? What? What's that?
2. No, 2.
Oh, okay, it's half of it, you're right. You take half of that number, so it's minus 4 squared. But then you're going to say, you have to also minus the square of this one, minus 4 squared. And if I had another number, I would add it by a dot, okay? This is, I know you probably don't remember, you're going to have to teach yourself how to complete the square. I'm just saying that's how we do. We take half of this, square there, and then minus the square of this, minus square of this thing. So what we will get, I'm going to write it again here, PQX equal minus x minus 4 squared. I'm just multiplying that by this, and then I'm going to multiply that by that. Plus, what is 4 squared? Plus 16. Okay? What we've done now, okay, we took this quadratic expression and we completed the square. Now, why did we do that? Because Jojo reminded us that by reading the completed square, we can find out what's the maximum value. And the maximum value of PQ will be 16. Okay? So, we'll write it down like this. PQ max is going to be equal to 16. I'll quickly remind you, kind of hopefully convince you that this 16 is the maximum value. This equation, both of these, are smiley face or sad face?
Sad face.
It is a sad face because of that minus. But now this whole term is forever negative. Why is it negative? Because this thing is always positive. The square of something is always positive. But now I'm slapping a minus on it, so this thing is always negative. So the highest that it can be is 0. So when x equals 4, this whole thing is 0. That's the highest thing that it can be. Okay, the maximum that PK can be is 16. I'm going to pause here, answer some question, no doubt.